As a part of our lecture series on vector valued functions, we have already defined velocity, acceleration and speed of a moving object. In this video, we are going to find the velocity and position vector of a moving object at time t if the acceleration at time t, initial velocity and initial positions are given. Example: a moving object has an initial position and initial velocity given by the vectors vector r of 0 is equal to I plus 2j plus vector k and vector v of 0 is equal to I plus 2k. Its acceleration at time t is a of t is equal to 6ti plus vector j plus 2k. Now we have to find its velocity and position at time t. So the acceleration, initial velocity and initial positions are given. We know that acceleration a of t is equal to v dash of t. So to obtain v of t, we need to integrate the acceleration. So vector v of t is equal to integral a of t dt, and that is equal to integral 6ti plus j plus 2k dt. That's equal to 6t square by 2i plus tj plus 2tk plus vector c. Now we need to find this vector c, and for that we use the condition v of 0 is equal to I plus 2k. From here we have v of 0 is equal to c and that is equal to I plus 2k. So v of t is equal to 3t square, here 6t square by 2, and plus 1 of this c vector I plus tj plus 2t plus t of plus this 2 of vector c, therefore 2t plus 1 vector k. So v of t is given by this. Now we need to find the position vector of the particle, or r of t, and we have v of t is equal to vector r dash of t. So to find r of t, we need to integrate v of t. So vector r of t is equal to integral v of t dt, and that's equal to integral 3t square plus 1 I plus tj plus 2t plus 1 vector k, and this is equal to integral 3t square, that is 3t cube by 3 or t cube plus t vector I plus t square by 2 vector j, and 2 into t plus 1 2t plus 2, that is plus 2t square by 2, that is t square plus 2t vector k plus vector d. And for finding this vector d, we use the initial condition vector r of 0 is equal to I plus 2j plus k, and from this equation we obtain vector r of 0 is equal to d. So that's equal to vector I plus 2j plus k, and therefore vector r of t is equal to t cube plus t plus 1 of vector d I plus t square by 2 plus 2 vector j plus t square plus 2t plus 1 vector k. Thus we obtained the position and velocity vectors of the given moving particle from the acceleration and the initial position and velocity. We can have another example. Find the velocity and position vectors of an object with the acceleration a of t is equal to e raised to t 0 e raised to minus t, and whose initial velocity is v of 0 is equal to 1 2 0, and initial position is r of 0 equal to 3 1 2. Now we need to find the velocity, and from the fact that vector a of t is equal to v dash of t, we have v of t is equal to integral a of t dt is equal to integral e raised to t vector I plus 0 j plus e raised to minus t vector k, and that is equal to e raised to t vector I minus e raised to minus t vector k plus vector c. And to find the vector c, we use the initial condition v of 0 is equal to I plus 2j plus 0k, and from this equation 1 we have vector v of 0 is equal to e raised to 0 1 I minus k plus c, and that is equal to I plus 2j. So vector c is equal to 0 I plus 2j plus k. Therefore v of t is equal to e raised to ti plus 2j minus e raised to minus t minus 1 k. And we know that v of t is equal to vector r dash of t. So to obtain our vector r of t, we integrate v of t with respect to t. So vector r of t is equal to integral v of t dt, or that is equal to integral e raised to t vector I plus 2 vector j minus e raised to minus t minus 1 vector k dt, and that is equal to e raised to t I plus 2tj minus e raised to minus t integral plus e raised to minus t plus t. Okay. Plus vector d. To obtain vector d, we use the initial condition vector r of 0 is equal to 3i plus j plus 2k, and using equation 2 we have vector r of 0 is equal to 1i, that means I plus k plus d, that is equal to 3i plus j plus 2k. Therefore vector d is equal to 2i plus j plus vector k, and therefore vector r of t is equal to e raised to t plus 2 vector I, this 2 is taken from vector d, and plus 2t plus 1 j plus e raised to minus t plus t plus 1k. We obtain the position vector and velocity vector of the given moving object. Thank you.